Thank you. So, good afternoon. When we usually think about our source code, we think about it in terms of a script, don't we? A script like when playing theater. A script that tells us what has to happen when. And this metaphor is quite, let's call it, control flow centric, and it's also quite fine. However, if you want to succeed with reactive programming, if you want to succeed with signals, you need to switch your thinking a bit. Because in the world of signals and reactivity, it's more like a marble run. A marble run where several marbles are going through. And those marbles represent your data, your state. And the state in turn is represented by signals nowadays. And sometimes some of the marbles can be split to several marbles, and sometimes several marbles can be combined to one marble. This is what we do usually with computed or the resource API. At the end of this marble run, some marbles are coming out, and those marbles represent data we want to display to the user. Because otherwise we did not need it. And displaying it to the user is usually done via data binding. Usually, in most frameworks, and Angular is no exception here. However, there are some exceptions sometimes. Sometimes you need to trigger a method to invoke a function in order to display something to the user. Think about displaying a toast message. Think about drawing on a canvas. This is more of an exception, and I will cover this in some minutes. The thing is, you really need to adjust with this way of thinking, with this more data flow and not control flow centric way of thinking. Without this, you will fail. Because, and here is the story, when I started with signals, my impression was, oh, they are that cute, they are getters and setters, I'm really good with calling getters and setters, it's fine. However, if you just look at signals that way, and if you stick with your traditional way of programming, you will run against walls. You will have a lot of troubles, because the API was designed in a different way, for a different paradigm. That means you will swim across the stream, and this is nothing you want to do on a regular basis. And that's why this entire metaphor with the marble run and also this talk here is that important for me. So the basic question I want to answer today is this here: how to switch over to a more data flow centric design using signals and a brand new resource API. Or to put it in a shorter way, how to switch over to reactive thinking. To answer this question, I have prepared three things. We will get started with the so-called signal graph, which is the technical representation of our marble run. That means this marble run is for real. It lives inside your Angular application in the form of a data structure, the so-called signal graph. We will look to it a bit. Then we will look into a demo application using signals and the resource API. And finally, we will discuss the signal graph in this application so that you see the bigger picture. Before I start, let me introduce myself. I'm Manfred. I'm a trainer and consultant for Angular, and I'm helping a lot of companies with Angular in the enterprise. In this role, I'm visiting these companies, I'm doing workshops there, I'm doing consulting there, I'm doing reviews. And besides this, I'm also quite connected to the Angular community. I live in Austria, I do a lot of stuff in Germany. Since 2008, I'm here every second week. I'm traveling across the States. I'm enjoying to find out about the little differences of the German federal states, and I'm helping companies with Angular in the enterprise. Sometimes I'm also allowed to enter other countries when I promise to behave well. Most of the times this works quite well. For instance, Switzerland or Poland or the Benelux states. Okay, cool. So let's talk about the signal graph. And to motivate this topic, I want to start with a very, very simple example. I have a more complex later, but we are starting with a simple example. You know, it's like a Hitchcock movie. In the beginning, everything is easy, and then little by little, it's getting tough. But in my little example, it's about a very tasty topic. It's about cakes. Here I have a signal with an array of cake. And I have also here my selected signal pointing to one of my cakes. Here it's pointing to the cakes at index position 2. Then I have a computed signal. The good thing about computed signals is they automatically stay up to date. If one of the ingoing signals is changing, this computed signal will be automatically recomputed. It will automatically be recomputed, at least as when someone is interested into it. When no one is interested into it, then it won't be recomputed. So it really works in a lazy way. That means we can have a projection here, a view model that stays up to date for our purposes. So here we are getting out the name of the selected cake, then I'm putting it into a resource. To be more precise, I'm calling here a factory function for a resource. The resource is set up internally because I don't want to pollute my data flow here. We will look into the inner workings in a second. But the important thing here is that the selected cake goes in. In there, a resource is constructed. And every time the signal is changing, the resource is starting working. You know, like the Duracell bunny in the advertisement, it's starting working. It is fetching data from somewhere. And this data can then be represented by the value of the resource, details about my cake, or perhaps there is an error. Sometimes this happens, people say, and then I'm getting back an error signal. So now, if you look at this simple example, you already see our data flow, our marble run. What you see here is we are starting with a red marble and a pink marble. And both are going into this computation. We are getting back a blue marble that is going into the resource, triggering the resource whenever it changes. And the result of this resource is represented by the value or the error. So at the end of the day, we get a light blue or a black marble, somehow hopefully displayed to the user. This is our marble run, our signal graph, and we need to think in terms of this data structure. And this signal graph is for real. Meanwhile, you can even visualize it. The Angular DevTools have a feature, it's currently in preview, but if you activate it, you see your entire graph here in this shape. For instance, here you see my cake signal, selected signal, and also my selected cake. Here it's ice cream pancakes. And then I have unnamed. So what is unnamed? Well, unnamed is my resource. The DevTools are currently in preview, and that's why they are not able of displaying a resource. Instead of the resource, they are looking to the inner workings of the resource, and there the DevTools sees some signals. I think 3 or 4 different signals. So hopefully in the future, when this is more major, we will see the entire resource fetching our data. Okay, so this flow here is for real. And now I would say, you know, Hitchcock principle, let's go on with a bit more exciting and more difficult example, which is Super Mario. Who knows Super Mario? Of course, everyone, that's great, I love you. So actually, Super Mario was one of the first games I played, and I really urged my parents to buy me this Nintendo so that I could play Super Mario. And some weeks I played it again, some weeks before, and it's really funny because I did not play this for ages, and still I know exactly where all the hidden items are, the extra lives, and which pipes I can use to go to the bonus levels in the underground. And by the way, this year it turned 30. So this really shows that we are getting old, don't we? So let's have a look into the Super Mario game. I've implemented Super Mario for JavaScript and for Angular, because why not? And here we go. So this is the first level. And I can do several things here. I can switch the level. And I can switch the theme. You have 4 themes in Super Mario. And usually a theme is directly connected to one level. But in my implementation, you can freely switch between the themes, between overworld and underground and underwater and castle. And you can play it. Look at this. So it's really a lot of fun. And yeah, it ends with death. I'm very sorry. And then we are respawned. So let's have a look at the implementation of this. So what I did to implement this in JavaScript, I borrowed a tiles map from the internet. You find a lot of resources in the internet, like here all the tiles you need for Super Mario. Super Mario when standing, Super Mario when running, Super Mario when jumping, and so on and so forth. And I also borrowed another tiles map with tiles for the levels. And here you really see a level in Super Mario is nothing else than a set of tiles arranged on your screen. And what's also nice here, we can easily switch between the themes by adding an offset. So if I add an horizontal offset, I'm landing over there in the underground theme. If I'm adding a vertical offset in addition, I'm landing there in the underwater theme and so on. So switching between themes is not that difficult here. What do we have else? Well, we have here a level description file that tells us you have level 1 and level 2. And for each level, you have another level description file. And this is really funny. My 9-year-old watched me modifying this JSON file, and it was at least as amazing for him as it was for me, because here I can define how the level looks like. Like I want to start with a floor at these coordinates, and I want to repeat the floor 55 times from the left to the right. This is what you see here. I'm starting here with the floor, and I'm repeating it 55 times from left to right. Or here I have the cloud up here in the sky, and somewhere we have a brick and a question mark. So in theory, as it is open source, someone could implement a level editor. So far, we need to deal around here with those JSON files. Yeah, lots of fun. However, another thing that is also a lot of fun is that we can modify those style maps. It's just a PNG file. And of course, what is the first thing a developer does when they find out they can modify a tiles file? They modify it. They squeeze something other into it. And this is where I remembered that the Angular team had this discussion about the mascot. And one candidate is the helmet guy here. I just call him Helmet because it sounds like this German name. And so I squeezed in Helmet to my tiles map. Here we go. And now let's activate this tiles map. And now we have our first 8-bit Angular hero game. So, lot of fun. Awesome. So now let's come back to the idea of the signal graph. Let's talk about the signal graph in this very example. So first of all, you have a signal for everything you can see as a user, or you can modify. For instance, there is a signal style. It points to the theme you have selected. For instance, overworld, underground, you know. Then you have a play signal. It holds a boolean, telling us whether we are playing or just looking at our different levels. Then we have a level key. It points to the level we have selected, first level, second level, and so on. And we have a canvas. Of course, we need to paint on a canvas to get Super Mario moving and so on. Then the rest of this is interconnected with resources. For instance, there is a tiles map resource that is loading this entire tiles map, you know, with bricks and coins and floors and so on. I'm doing the same with the hero map. And there is my level resource. So let me have a look. Yeah, level resource. And this label resource is connected to the label key. That means when the signal label key is changing one more time, the label resource starts working. It loads this JSON file with all the descriptions. Then I have a tiles resource. It takes the tiles map and it takes the style, and then it is extracting the right tiles I need for this tile, respecting all the offsets from the left to right, from top to bottom. So this gives me a lot of little tiny images I can arrange on my canvas to construct the label in question. I'm doing one more time the same with the hero. Then, for the sake of completeness, I have a label overview resource that loads the file that is telling us you have level 1 and level 2, and you can switch freely between it. And then everything comes together. In the middle of this, we have an effect. We have an effect that is accessing all the other data, the loaded data, the derived data, and using it to paint something on a canvas. And here is the thing. Usually, you should really avoid effects when it's possible. And now this ties back to the beginning. You should use data binding to display something to the user. However, when it comes to displaying something on a canvas, using data binding is really, really difficult, isn't it? And that's why you need to trigger a method that starts painting there, and that's why we need an effect. So while you should usually avoid effects, this here is an ideal, typical use case for an effect. To use a little metaphor, the effect is connecting your reactive world with the imperative world. The world with the data flows, with the world where we first of all look at the control flow. That means at the end of this marble run, we are sitting and waiting, and every time a marble is coming in, we are doing a little tiny script. And as mentioned before, this is usually done when you need to display something you cannot display with data binding, like toast message painting on a canvas. Okay, let's have a look at this example. In this example, I'm moving over to my level component. And here you see it is starting quite nicely. We have a lot of signals representing everything the user sees or the user can touch. Even our canvas is meanwhile represented by a signal, because the new view child that allows us to get hold of the canvas is meanwhile signal-based. Then we have some resources. For instance, here I have a method that gives me my tiles map resource. Let's have a look into it, how we construct it. Well, to construct a tiles map resource, we just need to call httpResource, and then we are passing in a lambda expression with some key data, like the URL of my tiles map I want to load, or whether I want to see progress information. This might be in handy when you download something that's a bit bigger, because then you want to know that I have now downloaded 10%, 20%, 30%, and so on. In this case, you can look up your progress signal to find out about the, progress. So what do we have else? If you want to load something that's binary, and yes, of course, my tiles map is binary, then you can just go with this secondary function, as I want to call it, blob. There is also an array buffer method and a text method for loading plain text. If you want to load JSON, then just call httpResource as a function. In this case, you can also type the result level, which means you will get back some level objects in this very case. Let's move back to the blob, because this is what works. Inside there, in the resource, we have further stuff next to the URL, and report progress, we have all the stuff we already know from the HTTP client. We can define headers and we can define the method get or post or put. We can define URL parameters. And every time one of the signals in there is changing, let's say you are calling a signal here, my signal is just pseudocode. Every time one of the signals in there is changing, resource starts acting like the Duracell bunny, it will load some additional data from the backend now, respecting this signal as a parameter. Quite straightforward. Yeah, so one last thing before we move on with the signal graph, the resource is only for fetching data. Even though you can define a method like put and post, even though you can define a body, a payload you want to send upwards, it's just for fetching data. The option to move over to post or put is just because we cannot foresee what kind of API we have. Sometimes the API might force us into fetching data via post, even though we all know it's not intended that way. Okay, this here is my resource that I'm constructing in getTilesMapResource. That means we have a signal here for everything the user sees. We start with our TilesMapResource in there. Then here I'm creating my tiles resource. I'm passing in my tiles map. I'm passing in the style. You remember overworld, underground, underwater, and this gives me the tiles resource representing the little tiny tiles in the right theme. I'm doing the same with the hero. I'm loading my level overview resource. You remember the level overview resource that tells me you have level 1 and level 2. And then I'm loading my level resource. Whenever the level key is changing, the level resource will kick in and load the next JSON file. This is more or less my data flow. A lot of marbles triggering further marbles, triggering other marbles in addition. Then here we have an effect, a lazy one and a very boring one that is just initializing the canvas. The second one is interesting. The second effect is calling render. It is collecting all the data from my signals, from my resources. And whenever one of those data items is changing, the effect will automatically rerun. And the rerun of the effect will start the level when the play button was pressed, or it will just render the level when play is not true. And that's it, more or less. Nice data flow that ends up in a canvas like this. Awesome. So if you say, yeah, I like those ideas, I like how Manfred is connecting those ideas on the abstract level, on the conceptual level, and how he is breaking it down to the code level, then you find more information about all of this here. So if you like it, download the book. If you don't like it, then download it either, because perhaps I'm better with writing than with speaking. Who knows? Okay, so let me sum up. What did we see today? Well, basically, we have seen 3 things today we should keep in mind on a conceptual level. One thing is we need to think in terms of data flows, because reactive programming is more data flow centric. That's the first thing. The second thing is we should use those functions like computed or resource to build a reactive graph, to derive some data items from other data items so that we see how data is flowing down. And as a rule of thumb, when the derivation is synchronous, you go with computed. If the derivation is asynchronous, you go with the resource. Asynchronous, like fetching data from somewhere. And the third thing is, usually you want to hide the details of creating your resources in a function or in a service method. because you don't want to pollute your data flow and you want to construct it in a well-defined way, perhaps inside of your data access service when it's about fetching data. And last but not least, there is one thing I really want you to recognize, namely, think about your application in terms of a marble run. And that's it. So thanks for having me. I've already uploaded my example Super Mario and the slides to our blog. You find it here. And follow me on social media so that we can stay in contact. Thank you.